forever, so I'm going to start that. Hopefully we get some. Oh, let's see. Let's wake her up. We're working on stoichiometry, which is the conversion of, well, on Tuesday. Tuesday? Really? Was it Tuesday? Uh, and oh no, that was bad. Undo. I don't want to delete a whole page. I wanted to delete that move. Converting mass to mass, and it's usually when you hold the pen thing over the tablet and then try to use the touchpad. Converting a mass to moles, converting a moles to moles using the stoichiometry step. Like these are all the same. Any stoichiometry, regardless of what unit you're given and what unit you're asked to find, it's convert something to moles, do the stoichiometry step from moles to moles, and then do the last step. So far we can do this. We technically could do pressure. And we went through those examples. That's kind of our framework where we have to find a molar mass. Find, like you need to put those numbers, those four numbers you have to figure out, and then do our calculation. Did we? Oh, Jaden's here. Ryan's here. We got everybody out of bed. Too early. I've been up for 4 hours. Yes. You have siblings. You should wake them up. When you're done here, you should go wake them up and tell them it was me who said they should wake up, and we'll see how that goes. Uh, oh, that's okay. So I'm really going to go through a couple things today, just reinforcing, and then there's some stuff to practice. These all kind of don't have an equation, so I'll give you the equations. And what was that? Apparently that was some of the answers. So 10 grams of iron are added to a solution of copper sulfate. How much copper would form? So I did this equation um, on and like an assignment for now. I'm going to give you an equation. So you're starting with iron. This one's nice and simple because we want to know iron. We want to know copper. Um, I think I know the two molar masses, but I need my periodic table to be sure because I think one's 55.85 and 63.55 are my two guesses. So I'm going to look those up before I start doing this. Once that blue circle of annoyance goes away. Like today, please. Oh, there we go. Oh, almost. Copper is 63.55, iron is 55.85. So if you write your molar masses down to start, so the mass that we're given, we're going to 10.1 grams of iron. We want to find way over here grams of copper. So I don't want grams of iron. I need to convert this to moles. So 1 mole of iron weighs grams of iron, and grams of iron go away. You do that calculation, get moles of iron. I don't want moles of iron. I want moles of copper. Well, we take these two numbers. There's in the balanced equation, assuming I balanced that right, which I'm pretty sure I did. 3 moles of copper come from 2 moles of iron because everything is all happily balanced. Moles of iron cancel, moles of iron cancel. Okay, we do this, you would get however many moles of copper. Okay, that's all well and good, but we want mass. So we want to find a mass of copper. So we want to get rid of moles of copper, grams of copper. The relationship here is 1 mole, 63.55. Moles cancels with moles. The units that we have is the units that we want. Now we pull up our handy dandy Windows calculator. Well, I do. 10.1. Oh, don't point. That's in the bottom of that, so we divide by 55.85. Next one times 3 in the top divided by 2 in the bottom, and then 63.55, whoops, is in the numerator. So if you look, divide by the molar mass, multiply and divide by the mole ratio, and then multiply by the last molar mass, gives us 3 significant figures, 17 grams of copper. So I could potentially say how much iron sulfate would be produced. And what changes is the first step doesn't change. Those would change because if I'm looking for that, we would have to put that there. That molar mass does, but the same framework, other than the back part of the question, everything is staying the same. So that's a mass stoichiometry question. This shows how old and all of that. The U.S. Space Shuttle boosters used to use this reaction because we don't have a space shuttle anymore. 3 aluminum plus 3 ammonium perchlorate produces aluminum oxide, aluminum chloride, nitric oxide, and water. It's part of this. They're probably looking to make nitric oxide to burn stuff. So that's an equation. Who cares what the equation is? How much aluminum must be used to react to 652 grams of ammonium perchlorate? So I have my stuff. I'm going to just quickly 3L. So we're given in the question 652 grams of that. We want to know grams of this. Well, I can do the molar mass of aluminum fairly quickly. This is ammonium perchlorate. So let's add that up. Nitrogen is 14.01. 4 times 1. Whoops. Plus 35, 45, plus 32, and 32 is 64. So the molar mass of this is grams per mole. So what mass are we given? What do we want to find? Grams of aluminum. I want to get rid of grams of that, so I want to convert it to moles. Over grams. Grams go away. This is nice and straightforward because the equation says 3 moles of ammonium perchlorate is used, produces, or we need 3 moles of, oops, Moles and moles go away. I don't want moles of aluminum. That weighs. And then we multiply. 652 and divide. 117.5 times 3 divided by 3. If the numbers are the same, that is redundant, but it's still necessary, times 26.98 grams of aluminum. So that was 140, 150 grams of aluminum. Well, 3 moles needs 3 moles, so if I find the number of moles of this and convert it, well, this makes sense that that number is smaller because there's a factor of almost 5, 4.5. Now, if I use the same thing and say how much water is produced, well, the only thing that really changes, I want to know this mass. That would be 18.02. Go away. I can do this now. This first part, because I'm still converting that to moles. The molar mass of that hasn't changed. I want to get rid of that. Well, now we want to switch this to moles of water, because I said how much water, so grams of water. We go back to the equation. It says 6 moles of water. Well, that's different. I don't want that. I know this weighs. So we've changed those last 3 things. Grams cancels with grams, moles cancels with moles, moles of water cancels with moles of water. We have that. And 652 divided by times 6 divided by 3 times 18.02 divided by the molar mass times the and divided by the ratio times the second molar mass would mean we would need, or we would produce, 200 grams of water. So the framework, even though I change what I'm looking for, the equation's the same, I could give you, with that particular given, how many grams of this, how many grams of any one of those are produced. This first kind of part of the equation, it's the same all the time because I want to have moles of this and then I want to get rid of it. And then we can modify that back half. So that's what I was going to look at today. These are 6 ones to try. The numbers in brackets, I'm pretty sure, are the correct answers. Whoops, I need a pen to. Zinc reacts with sulfur. Sulfur is S8 to make zinc sulfide. And that's there to play with the stoichiometric. Bauxite ore contains aluminum oxide decomposed using electricity to get aluminum and oxygen. I'm going to need a 2, a 4, and a 3 there. Determine the mass of oxygen to completely burn propane. 4, and 6 are 10, so 5, 1. Calculate the mass of lead 2 chloride precipitate formed when sodium chloride in solution reacts in a double displacement or replacement reaction with lead 2 nitrate. Well, it says that's a precipitate. +1, -1, +2, -1. So we need those, and oops. I'm going to need 2 of those. So you're given grams of this. How many grams of that do you form? Predict the mass of hydrogen produced when aluminum reacts in a single replacement reaction with sulfuric acid. Aluminum is +3, sulfuric acid is -2. I'm going to need 3 of those, 2 of those. I'm just going to rewrite this. Technically, that's a gas. Bubble, bubble. Something we would do if we were in school. Well, we wouldn't use aluminum and sulfuric acid, but we would do the same thing. Mass of copper 2 hydroxide precipitate formed. CuOH2 solid plus 2, 2. So you know this, you're looking for that. Predict the mass of hydrogen gas, you're looking for that. You're looking for that. That. That is what we're looking for. Powdered zinc gas, predict the mass of sulfur required. And that. So if you want to try to practice these, the answers are there. I'll go over any of them if anyone has any questions on those tomorrow. But then after that, we're going to talk a little bit about quickly what the concept of limiting reagent is and yield. And that's the end of chapter 12. Some of the stuff in 14, 15, and 16 are like a day long. But that's all we have for today, unless anyone has any questions.
For the assignment, is it like the whole thing or is it certain questions that have to do?
Let me check. That's a good question.
I only found questions 7.
Oh, the balancing one?
Yeah.
Uh, that's probably because, um, yeah, like I took it from an old. Oh, you moron! I'm gonna edit that, and yeah, you only have to do 7, 8, 9, and 10. I didn't realize the old because you've already done some of those ones. I'm sorry. It should be on the second page. Just those 2 equations to balance. Which one of them gets significantly easier? Yeah, I'll edit that and um, just edit that document to update that. I don't know who's turned it in so far. So if you can go find that last question, Jaden, do that one and add it to it because I think you guys can update that. I'm sorry about that. It's last year when I was in the lab and had to do A's and B's for everything. I will fix that and update it. And yeah, it's just the balancing equations stuff. Shoot, moron. Students can't edit, but can I edit? Okay, I'm gonna have to go back and fix that. Yeah, I don't need to waste your time. You guys need to go and enjoy the sun or come back in. For a couple of you, come back in half an hour. Go take a break. Sound good?
Mr. McKay, I had another question.
Oh,
Sorry.
no worries.
For 9A, how do we find the state of the products?
9A. So you're going to do your double replacement reaction, right? When you do those ones. And then when you go to your periodic, you need to pull up this solubility chart. So look at your products based on your anions and see whether it's aqueous if it's up on top or a solid if it's something down on the bottom.
Okay, thank
Okay,
you.
no problem.
Yeah,
Anything else? Or are we good?
good.
Awesome. I will see you guys tomorrow.
See ya.
Have a good afternoon.